The James Webb Telescope has just unveiled the clearest image of Proxima B to date, captivating the attention of scientists and space enthusiasts worldwide. This remarkable achievement opens up a realm of possibilities and ignites our curiosity about the secrets this distant world may hold, including its potential to support life. Let's delve into the exciting discoveries unveiled by the James Webb Telescope. The James Webb Space Telescope, or JWST, represents a significant leap forward in our exploration of the cosmos. By peering billions of years into the past, we can witness the birth of galaxies thanks to the remarkable capabilities of the JWST. The infrared images captured by this powerful telescope provide us with an unprecedented view, unlike anything our eyes have ever seen. Just as the filters on your phone's camera enhance your images, the JWST's capabilities depend on how it is utilized. One of the primary goals of the James Webb Space Telescope is to enable astronomers to study the early universe and gain a better understanding of the formation of galaxies, stars, and planets. By analyzing the nuances and details within these images, researchers can extract valuable insights. The telescope's advanced camera and filters allow astronomers to collect specific ranges of colors of light, providing valuable information about distant celestial objects. Additionally, the JWST will investigate the atmospheres of exoplanets beyond our solar system, searching for signs of extraterrestrial life. The ability of the JWST to peer back in time and explore the farthest reaches of space has already yielded significant discoveries. For instance, astronomers have used this extraordinary telescope to detect previously unknown mass within the universe, hidden within several massive galaxies. These discoveries about the evolution of space expand our knowledge and push the boundaries of our understanding. Proxima B, the planet at the center of this recent image, has been a subject of great interest since its discovery in 2013. Astronomers initially detected hints of a tiny gravitational pull exerted by a planet on its star, leading to the identification of Proxima B. What makes this planet particularly intriguing is its orbit around Proxima Centauri, the star system closest to our own after the Sun. Observing the Alpha Centauri system, located approximately 4 light-years away, allows us to witness events as they unfolded 4 years ago. Proxima B holds a unique position among astronomical discoveries, being a mere 25 light-years away from Earth and ranking as one of the closest exoplanets ever found. However, despite its proximity, Proxima B is a world vastly different from our own. With approximately 30% more mass than Earth, Proxima B is larger in size. Yet, its orbital period lasts a mere 11.2 Earth days due to its close proximity to its star, Proxima Centauri, at a distance of only 7.3 million kilometers, less than 5% of the distance between Earth and the Sun. Although one might assume that a planet so close to its star would be scorching hot, Proxima Centauri is a diminutive red dwarf star that emits significantly less energy than our Sun. Therefore, if Proxima B resides within the habitable zone of its star, it may possess the conditions necessary for liquid water to exist, an essential ingredient for life as we know it. However, before embarking on interplanetary adventures, it's crucial to recognize that Proxima B is far from a second Earth. One distinguishing factor is the high likelihood that Proxima B is tidally locked with its star, resulting in one side always facing the star while the other remains in perpetual darkness. This extreme contrast creates an inhospitable environment for potential life forms. Furthermore, any water that ventures too close to the star would be boiled away by its powerful radiation. On the contrary, if a planet orbits too far from its star, it risks freezing all its water. These factors suggest that Proxima Centauri may not be as life-friendly as initially thought. Recent studies utilizing high magnetic field maps have shed light on the conditions surrounding Proxima Centauri. These investigations revealed that Proxima B receives approximately 1,000 times more radiation from the solar wind than Earth, presenting a significant challenge for any potential life due to the star's powerful flares. In fact, a flare observed in April 2021 on Proxima Centauri was 100 times more powerful than any flare recorded on the Sun, making it difficult to envision how life could survive under such conditions without specialized shelter. While the idea of a habitable planet orbiting Proxima Centauri is fascinating, the reality seems far less hospitable. The fascination with encountering extraterrestrial life has long captivated humanity. In late 2020, this intrigue reached new heights when an unusual signal was detected emanating from the Alpha Centauri system. This signal, which resonates at a frequency of 982.07 MHz, differs from typical signals produced by Earth's satellites and spacecraft. While some experts speculate that the source may be human-made equipment, others continue to dream that it could serve as evidence of intelligent life. Embarking on a journey to Proxima Centauri, the nearest planet outside our solar system, and encountering alien life may not be as far-fetched as previously believed. The Breakthrough Initiative has explored the possibility of reducing travel time from hundreds of years to a few decades. Recent research has demonstrated potential technological solutions to overcome the challenges of accelerating objects as their mass increases, particularly as they approach the speed of light. However, with current technology, reaching Alpha Centauri, even as the closest star system, would still require approximately 6,000 years, making it an incredibly difficult feat. The Starship project, designed to reach Alpha Centauri, contemplates utilizing lasers to propel the spacecraft to its destination. However, one significant obstacle lies in Earth's atmosphere, which interferes with incoming light and laser radiation, making it challenging to apply the necessary force for propulsion. Bandutunga, the lead author of a related study, proposes using adaptive optics in the opposite direction to overcome this predicament. By employing small lasers on satellites to evaluate atmospheric effects in real time, ground-based lasers could maintain a precise focus on the space probe. Implementing this system requires an astounding 100 gigawatts of power, equivalent to the entire electricity consumption of the United States, although the lasers only need to operate at maximum power for 10 minutes. To distribute the electricity over a square kilometer area, the plan involves utilizing 100 million lasers. The Starship team seeks to push the boundaries of space exploration. Once the lasers are deactivated, the spacecraft will hurtle through space at an astonishing 20% of the speed of light. With a diameter of just over 10 meters, it could reach Alpha Centauri in a mere 22 years. However, the gravitational pull exerted by the Sun and interstellar debris could considerably slow its progress. Even if the spacecraft manages to reach Alpha Centauri, it would take an additional 4 years for any data or communication to return to Earth. The most critical challenge lies in preventing the probe from melting as it travels through space. To mitigate this, the spacecraft's mirror must be nearly flawless, reflecting 99.99% of the incident light. Additionally, it must facilitate efficient momentum transfer while minimizing heat buildup within a matter of days. Once launched, the probe will traverse the Alpha Centauri system, likely without approaching Proxima B. One intriguing aspect of this concept is that once the launch system is established, subsequent probes could be sent at a reasonable cost. This significantly increases the chances of glimpsing Earth-like planets if fleets of probes explore neighboring star systems. The possibilities are boundless. After arriving at Proxima Centauri, humanity could explore an entire star system, potentially discovering numerous additional planets resembling our own. Exoplanets, which are planets outside our solar system, have already yielded thousands of fascinating discoveries. In 1992, scientists made the first official detection of planets orbiting a pulsar, a particular type of neutron star. 3 years later, the first planet was discovered orbiting a star similar to the Sun. Since then, numerous planets, including several Earth-sized ones within their star's habitable zones, have been identified. If you enjoyed this information, don't forget to click